NativeScript is a framework for building cross-platform iOS and Android apps using JavaScript. NativeScript is free to use, it's open source and up on GitHub, and it was created and is supported by Telerik. To see how NativeScript works in action, let's build an app. In NativeScript, you build and run apps from a command line utility that you install with npm. After the installation, you'll have two commands: NativeScript, which gives you a big list of all the commands that the CLI supports, and TNS, which is short for Telerik NativeScript and does the exact same thing. From there, you can use the TNS create command to create a new NativeScript application. For instance, this would create an app named Hello World. But to save us a bit of time, I'm going to switch over to a project I've already scaffolded out. Today we'll be building a small little app called Groceries, which will let users register, log in, and manage a basic grocery list. Let's look at the files that make up this app. The first thing to note is the use of the node modules directory in the package.json file. One of our guiding principles when building NativeScript was to let JavaScript developers leverage skills that they already have. If you've built a Node.js app before, or if you've just used npm to manage dependencies in a web app, these files will look familiar to you. If not, you'll see how they work momentarily when we use a few npm modules to help build this app. The two other directories you see here are app and platforms. The app directory is where you'll be spending most of your time, as it contains all of your development files. The platforms directory contains your actual native iOS and Android applications, so it'll have things like your Gradle files on Android and your Xcode project for iOS. The great thing about NativeScript, though, is that even though you can mess with these files if you really want to, you can open up your NativeScript app in Xcode, for instance, you can basically treat these native files as generated code. In fact, most NativeScript projects actually exclude the platforms directory from source control, as you can see this project does in its gitignore file, as the NativeScript CLI is capable of regenerating this platforms folder at any time. Now, as I said, you'll be spending the vast majority of your time in this app directory, and in that directory you'll primarily see three different file types: CSS files, JavaScript files, and XML files. XML files are where you declare your app's UI components. For instance, here's the simplest app that you can build with NativeScript, a simple Hello World. Now, you might be wondering, why would we use XML in NativeScript instead of something like HTML? The reason is that NativeScript converts each of the XML UI components that you see here into an actual native UI component for both Android and iOS. In NativeScript, there is no browser and there is no DOM. This label UI component you see here will actually be rendered as a UI label control on iOS and an Android.widget.textView control on Android. To see that, let's actually run this app. When you go to build iOS and Android app, there are a few additional system requirements that you must take care of. To do that, head to docs.nativescript.org, find the installation section, and scroll down to find the instructions. Once that's out of the way, you'll want to go back to your terminal and use the Tns Run command. What Tns Run does is take your development files from the app directory and injects them into the appropriate place in your platforms directory, builds a complete native app, so builds a native iOS application, and then deploys that app to an iOS device. In this case, because I provided the ---- emulator flag, the CLI deployed the app to the iOS simulator, and you can see it here. This simple architecture, where files are just being moved from the app directory into the appropriate spot in their native apps, makes a lot of cool things possible. For instance, once I have this app built and deployed, I can just use a single command, tns livesync, to watch for changes being made to my development files here, and when I change them, I'll make a quick update to the text here, actually see those changes get pushed out to my device. This workflow makes my development workflow really fast and seamless. I can even work on multiple devices at once. Earlier today, I built and deployed this app to my Android device. So to set it up for watch, all I have to do is run tns livesync again, but targeting Android instead. Now when I change my development code, I can see those changes rendered instantly on multiple platforms. Let's do something more interesting. The first screen of Groceries is intended to be a login screen, so I'm going to paste in a few more UI components to build it. You'll notice a few new things. An image UI component to show this image here, 2 text fields to allow for some user input, and 2 buttons to display at the bottom of the screen. The other thing to notice is the stack layout component. Anytime that you use more than one UI component in NativeScript, you need to tell NativeScript how to visually lay out these components on the screen. NativeScript provides 5 different layout mechanisms. The simplest, stack layout, which is used here, simply tells NativeScript to stack up the components either vertically, the default that's shown here, or horizontally. Now with this we have a fairly complete login screen, but it is fairly hideous looking. To improve this, we'll use the next of NativeScript's file types, CSS Files, to add a bit of styling. Now in your app, you can either put CSS rules in your app.css file for CSS rules that should apply to your entire application, or a page-specific CSS file, such as login CSS here. To start, I'm going to add a few things to the app CSS file to clean this app up. You can see that I now instantly have a bit of spacing here. One thing I want to note though is that even though NativeScript's CSS implementation is quite powerful, not all of the web's CSS properties are supported in NativeScript. Because NativeScript is building native interfaces, each of the CSS properties that you see here must be converted into their native iOS and Android equivalents. And some of the web's CSS properties just aren't possible to replicate in a native layout system, at least not without large performance penalties. You can refer to the NativeScript styling docs for a full list of the supported CSS properties. What is cool is that NativeScript CSS implementation, in addition to live sync, makes playing with the visual look of your native apps a whole lot of fun. It's really easy to swap out different values and to see what they look like. It's certainly a lot easier than messing with the equivalent. It's certainly a lot easier than getting into Xcode in Android Studio and trying to do something similar. And with that, we have a login screen that looks halfway decent, but it doesn't actually do anything. For that, we have to introduce the third of the NativeScript file types, JavaScript. You can see in my app that I already have a login.js file here, but at the moment the file doesn't do anything. It's actually completely empty. To make this work, we're going to have to tie this JavaScript file to the XML file that this page also uses. Let's start by adding a new tap attribute to the button on the bottom here. In this case, tap is an event handler that NativeScript invokes when the user taps this button. The attribute's value, register, tells NativeScript to run the register function in the JavaScript file when this button gets tapped. We can define that function with a little bit of code. I'll paste in here. The exports keyword is part of the common JS spec, which Node.js and a number of other JavaScript runtimes use. By assigning functions to the exports object, you expose that function to other modules that use this module. It's basically like your module's public API. In NativeScript's case here, the consumer of this JavaScript module is actually the XML file. So with this tie made, tapping on this button here now fires the tap event handler, which then invokes the register function that is exposed from the JavaScript file. Now that you have an idea of how the flow works, instead of showing an alert here, what we actually want to do is take the user to a register view, which I've pre-built here to save us a bit of time, which means we have to figure out how to navigate the user. In NativeScript, to handle common tasks like this, NativeScript provides a fairly large collection of pre-built modules. To navigate, for instance, I can bring in the NativeScript frame module. This require syntax is again CommonJS. Require is just a way to bring in another JavaScript module, and you'll see that we'll use this approach several more times to bring in a number of other modules as we build this app. Once I have this module in, I'm just going to replace the alert with a call to the frame module's navigate function, which will navigate me to the register view. I've already wired up the registration screen to my backend to save us some time, so I'm going to quickly create a user account, complete with a very secure password here, which I'll use for the rest of this demo. Now that I have this user account, I want to go back to the login screen and make it functional. And to do that, I really need another way to tie the UI components here to my JavaScript code. And to do that, we'll use NativeScript's data binding implementation. I'll start by pasting in some code, and then we'll look at how it all works. First, I'll bring in a bit more XML and a bit of JavaScript code as well. The new thing to note in the XML is the use of this double curly brace syntax. Now, if you've done any data binding with front-end frameworks like Angular, React, or Backbone, this syntax will probably look familiar. What this code is saying is to bind the text of these text fields, one for email, one for password down here, to the email and password properties on this page's binding context. Now in NativeScript, this concept of a binding context is another NativeScript module known as an observable. An observable, however, is really simple. It's really nothing more than a simple JavaScript object with a little bit of sugar to make NativeScript's data binding implementation actually work. You can see if I bring these things up side by side here, that the properties on this observable, I have predefined hard-coded values for email and password here, correspond with the properties used with the double curly brace syntax. And that's the reason why these values pre-display in my app here. In fact, if I update them, you can see the values changing on the fly. Now to get this login function, I'm going to switch out this observable with a version that I built earlier. In this new user view model class, I just added an extra function to log the user in based off the data that's within that object. So I'm going to define a new function called signin, paste it in down here, and then update the XML to tie the sign in button with that new function. The cool thing here is the data binding that I showed earlier doesn't just work one way. That is, changes that I make to my JavaScript code doesn't just apply to my UI components. The data binding is two-way, so that user input is automatically reflected on the backend code. Meaning, when I change my data here, these values are automatically available to my JavaScript. And this is powerful because it lets you keep your code really clean. You'll note that there's no code in here that says to do something like update the UI or grab the values from the text field, because that just sort of takes care of itself. And remember again that you are building native apps here. This isn't just data binding between a JavaScript object and a div. This is data binding between JavaScript objects and completely native iOS and Android controls. And in fact, if I go ahead and log in here, oops, let me fix that. You can see that out of the box I get some native-y things, like the hardware back button works on Android. And if I switch over to iOS here, and again input my credentials here, I get completely native iOS animations. Even the swipe from the side thing to go back. Now the last page of this app, the list page that I'm navigating the user to, is still completely empty. And the last task we have today is to build that up. And I want to start with another really common NativeScript UI component, and that's the Listview. So I'm going to close these up and bring up my list pages XML file and paste in a few new components. This code uses a new NativeScript layout, the grid layout, which we'll discuss momentarily. But for now, one UI component takes up the whole grid, and that's the list view. You'll note that the list view also uses a data binding approach, and we'll define this property in the list pages code behind file here in a minute. But the list view also requires a template that basically spells out how each individual item in the list view should be rendered. In this case, this is a really simple list view. All we're saying is for each item, just spit out a label with that item's text. To actually make this work, let's jump to this page's code behind file and paste in a bit of code here. A lot of what you see here should look familiar. We're again setting up an observable to act as this page's binding context, but this time we're using another NativeScript module, the Observable Array, and hard-coding a handful of objects that will be in the array by default. Again, note how the property in the observable, the grocery list here, again corresponds with the curly brace syntax that you see defined in the UI. But also note how the property on each individual object in this array also mapped to what's used in the ListView's item template. Let's see what this actually looks like, and to make logging in a little bit easier so you don't have to see me fumble through typing again, I'm going to hard code my credentials back in here again. And now when I log in and go to the list page, you'll see the hard-coded list of data that we defined in this file here. Now that you have an idea of how the flow works, I'm going to again swap out the observable implementation with one that's already tied to the user's account. And then add a bit of code that loads that list from the backend when this page loads. At the moment, this won't actually do anything. This is a new account I just created a minute ago. There's no actual groceries associated with this account. What I want to do is actually create some sort of mechanism in the UI here for the user to add groceries to their list. And to do that, I'm going to go back to the list pages XML file in here, and I'm going to paste in two new UI controls, a text field and a button. and you can see them appear on the top of the screen. Now the other thing I added were a few new attributes to the grid layout. A grid layout, as its name sort of implies, divides the screen into a series of rows and columns. This syntax that you see here says to create 2 rows, or divide the whole screen into 2 rows, the first of which has a height of auto, or as much room as the UI needs, and the second row has a height of star, or the rest of the height available. The text field and button are both given a row of 0, so they appear on the top of the screen, and the list view is given a row of 1, so it shows up on the bottom. The screen is then also divided into 2 columns. This syntax basically says to give the first column 2 star, or 2/3 of the space available, and the second column the rest of the space, or 1/3 over here. The text field is placed in the first column. The button is placed in the second column, as these attributes are 0 based, and the list view is given a call span attribute so that it spans both columns on the screen, as we'll see in a minute. Now that the UI is set up, let's make this all work. You'll see that the text field is bound to a grocery property, so let's go back to our JavaScript code and add that to the page as observable. The add button right below it is bound to an add function on tap, so let's add that as well. And really, that's all there is to it. I can now add groceries to my list. Need some bread, some milk, some apples, and they appear in the list view as expected. This example again really shows the power of NativeScript's data binding mechanism. All the add function needs to do is add an object to the observable array, and it can get which string it needs to add by just asking the data model to get the value in the text field here. And after the add is complete, to sort of clear out this text field, all it needs to do is reset that property on the observable. And with that, and just really a handful of lines of code here, we have a reasonably functional groceries management app that works both natively on iOS as well as Android, which I think is pretty cool. But let's add just a few more things to show off some of NativeScript's other cool features. My personal favorite is using Npm modules. Because NativeScript apps run JavaScript code, you have the ability to leverage existing JavaScript modules from the world's largest package manager in Npm. Now, not all Npm modules work in NativeScript apps. For instance, modules that are tied to the browser or the DOM, modules like jQuery, aren't going to work. However, most utility modules, so things like moment.js, underscore, Lodash, and so forth, work in NativeScript exactly as you'd expect. Npm modules are great for solving problems that are somewhat tricky to solve on your own. For instance, in this app, I'd really like to validate the user's email address on the login screen here, but the logic that goes into properly validating an email address is somewhat shockingly complex to get right. But the good news is several people have already done all of the hard work for us and posted that work up as modules on NPM. For instance, a simple search shows a quick and easy to use email validation module. To install this module, all I need to do is just grab the command from the site here, npm install email validator, go back to my terminal, and run that command. I'll add on the -- save flag so the dependency gets saved in my apps.package.json file. From there, all I need to do is require this new module. So I'm going to go back into my login screen here and require it near the top, and then use this module's API. So in this case, the validator module provides a single validate function. So I'm going to paste this in right before the user signs in. I want to check if the email, getting it from the observable up here, if that's valid, and if it isn't, I'm going to use another NativeScript module, the dialogues module, to show a little warning to tell the user that they've provided bad data. So because the dialogues module is also new, I'm going to require that up top as well. Then I'll go back to my app, and if I did everything right, if I screw up this email address here and try to sign in, I now get an alert that informs me when I screw up my email. Using NPM modules like this is pretty cool because leveraging these pre-existing solutions can really greatly reduce development time. And remember one more time that you're using these modules in completely native iOS and Android apps. If you weren't using NativeScript, you'd be struggling to figure out how to validate email addresses in something like Swift, Objective-C, or Java. And instead, you're just installing something from NPM and using it from JavaScript code. But it gets even cooler. In NativeScript, not only can you use existing JavaScript modules, you can also use existing native SDKs as well. Think things like CocoaPods or jars, Android SDKs, and so forth. And what I think is the coolest part is, through NativeScript plugins, you can actually use these native APIs in your app without having to go into native development environments like Xcode or Android Studio at all. There are two different places you can go to find NativeScript plugins. The first is plugins.telerik.com/NativeScript. This is our verified plugin marketplace, which is a collection of plugins that we verified to work in NativeScript apps. The other place you can look is NPM. If you do a simple search for NativeScript, you'll find well over 100 plugins that the community has written for various tasks: text-to-speech, language, maps, Touch ID, all sorts of things. For groceries, though, what I really want to do is add the ability for users of this app to share their grocery list with their friends and family. And for that, the NativeScript Social Share plugin is really perfect. Now, if you're an Android or iOS user, you might know that both of these OSs have sharing widgets that are built into the OS. And what this plugin does is just make it really easy for you to do to tie into those widgets from JavaScript code. So I'm going to head back to the terminal and install the NativeScript Social Share plugin. The Tns plugin add command is really just a lightweight wrapper around npm install. NativeScript plugins are still stored on npm. However, because NativeScript plugins can also include native code and native SDKs, the NativeScript CLI may need to do a bit of extra work to sort of put these files in the appropriate places, thus why there's an additional command that isn't just npm install. The installation is complete. I actually already had this in my app, so let's go ahead and use this new plugin. To do so, what I actually want is when I'm on the list screen here, and I have to complete my email address here, I just want to add a simple button up here that lets the user share the list that they see here. For this, NativeScript has another UI component called the action bar component. So I'll open up my list XML file and paste this in here, convert to spaces, and you'll see the button automatically appear here. Within the action bar, you can see changing the title that appears here. I can use action item controls, which are just the buttons here, and you can see that this action item defines a simple tap event handler, which calls a share function that I need to define in my JavaScript code. So I'll head back to JavaScript here. The first thing I'll do is require that new plugin that we just installed, NativeScript Social Share, using the same require mechanism we've been using throughout this demo. And then I'll go down here and define a new share function that simply grabs the list of groceries from the observable and builds it all into a single string that I then pass to the Social Shares plugin's share text method. And with that, I'll save this. And now on Android, when I sign in, I have a simple way that I can share and see the native sharing widget for sharing this information on Android and iOS as well. This is as far as we'll go with the Groceries app today, but let's take a step back and think about what we were able to accomplish. We built a reasonably sized native app for both iOS and Android, and we did so by writing JavaScript, some CSS, and a bit of XML, and by executing a few commands from the terminal. We didn't have to dive into Xcode, open Android Studio, or deal with any sort of complicated native processes. And I think all of that is pretty cool. Now, there's a lot more to NativeScript than what I was able to show you today. If you'd like to see more, head to nativescript.org and click the big Get Started button. That'll take you to the hands-on tutorial that you see here that'll walk you through building this exact same groceries demo, but to do so in a lot more detail. You can see there's a lot of content here, and in a way that'll go through a lot more detail than I was able to get into in this demo. Thanks for watching, and happy hacking on NativeScript.